Let's update our mod and our libraries to 1.21.7. Hello everyone, this is Ali Reza. Welcome to the Mentor Code Lab. Before I start, I should tell you that it's early in 1.21.7 and between all the dependencies that I listed, REI is still not updated. Same for the Cryptonaut. Although we are not using any one of them yet, however, you should be aware of that. And the versions are all here if you want to look. Worth mentioning that we are now using 1.11 for Loom. I updated my mod versions and every other version that is related to libraries. Again, the Energy API is still 4.2. However, the Reborn core and Tech Reborn are updated, so I assume that 4.2.0 is still working. And now I had to nuke every library I had in local Maven and started with GBase. We will move from one library to another one, and some of them like logger and reference and maybe config will be fast, and some of them may need some work. Again, before we dive into the updating, it looks like 1.21.6 had a bug and 1.21.7 came out really fast. It looks like it's a debugging version, but 1.21.6 had done some changes behind the scene related to rendering. They are moving toward a render pipeline and making it more advanced for the future updates. However, regarding the normal code, there are few places that we need to address. This one is not related to updates, but I have a typo here, so let's fix that one. Insertion. Now, the very first one that I have and is needing attention is info area in the GBase. If I just comment these two constructors and recreate the constructors, you see that instead of this vertex consumer provider immediate, now we are using GUI render state. And again, we say this.area equals to, well, basically, let's just copy paste. Again, we need another constructor. So constructor that accepts the area, and that's it. The other one that needs attention is the NBT serializer. NBT stuff had changed in 1.21.6 again. So if I go into the blog post, scrolling down, Minecraft changes NBT. Now you see that write NBT is now asking for a write view. So let's get it here. And read NBT is now asking for the read view. It may look like they did change things a little bit. However, you notice that now we are not accepting T as NBT and we are not using the registry lookup. Now, I'm not sure how should I address this because T was NBT element, but for sure we want that read view and we call it view. Okay. I'm not sure if it's robust enough or not right now. We will come back to this when we are dealing with different things like inventory and fluid and energy. So it looks like we don't have any other problem. Maybe this is a problem. We will take a look at that, but I think this should work. Now I need to publish this guy on local Maven. It will be fast. As it's compiling, let me talk about one thing. As you notice, I have this dependencies.property at the root, and here I was assigning the Loom version. If you open each one of these libraries, you see that on settings.gradle, I'm actually reading the Loom version there. And if you open any one of these, build.gradle, I have a comment on top of each one of them that is talking about the situation and why things are the way they are. Now we have, I think it's unchecked. It's not important. And we are done. Okay, now I need to go in order. I mean, after the GBase, I need to work on the next one that is glogger. However, glogger is depending on GBase, so I need to go into Gradle, Loom Cache, remap mods, graya, remove that base from there, and then on glogger, I need to sync Gradle. Hopefully it will work fast because we have everything cached. As you notice, we have 8.14.2, so this one is redundant anymore, and we can delete that one from .gradle. It helps a little bit because when you have multiple projects, each one of them has multiple instances of Gradle, then yes, be careful and clean the project as much as possible because in the long run, it will become a bigger file size on your hard drive that is not necessary. Although if you want to work backward on older versions, you should be careful to keep them done. So I will move it to the second monitor. I will right click on .gradle or anywhere else, and I will say reload from disk. It will cause another indexing and finding Minecraft version and everything. And when the index is finished, we can take a look. However, as I said, I assume that we will have no errors here other than might be slowing things. And as you see, this check mark shows me that I have no error in this file. It was expected because nothing has happened here, but I had to resync the Gradle and republish because now I'm depending on the base here, and because of that, I need to make sure that we are loading the base correctly here. And as you see, it published to Maven. Okay, The next one is the G-reference. This guy again should be okay, so I will delete the previous Gradle, then loom cache, remap, Jiraiya, remove the base, and G-reference. Please sync the Gradle. Okay, let's take a look at here. It should be okay. So G-reference, task, publish to Maven local, and then we can move toward the next one, that is config. So again, I will delete the older Gradle version, and I will go into remap mods, Jiraiya. Now you see that here I'm using both base and logger. Delete that. And this is one of the reasons that I have to go in order. Maybe at some point I will convert these to be a parent-child multi-project system, but right now I don't want to bother myself with that. So sync the Gradle and reload from disk. Now here's the thing. I don't see any indexing or finding Minecraft version, and I don't see my dependencies under Jiraiya. That's okay, because when you build these things and they build correctly, it means that they are seeing these annotations from my base and everything is working. Now, one thing that I want to talk about is that although it may build correctly, it's worth opening every one of the files and make sure that you don't have any error anywhere. And now that I'm sure that we don't have any problems anywhere, I can just publish this guy to Maven. Now for G-register, here is something that I want to talk, and I'm not sure how to handle it right now. If we come back to the blog and take a look at here, you see that under new Fabric API features, we have this section that talks about append tooltip. And right now, my items are not registering any sort of tooltip. However, this is the new way of assigning tooltips. Basically, you need a component that implements tooltip appender. Then you register that component, and somewhere under event system, you use either add after, add before, add first, or add last. And then you add your component to the registry of that event. Then on any item stack that you want to show this tooltip, you need to add your component to that item stack, meaning that if you want to add that component, you can add it at register time as a component and it should work. However, if we take a look at our code here, for example, let's start from top, by the way, these should be okay. Then we have this interface, that is okay. Our mixin shouldn't have any problem. Armor helper hopefully has no problem. This is the block item registry. This is the block registry. This is the component type registry. This is the entity registry that works both for block entity and entity, then item registry. Now here is where I can add some overloads to register items using components. And basically, if I want to, after the settings, I can say dot component. And as you see, I can add a component and t value. Honestly, reading this one, it doesn't talk about any values. You see, it's just saying that any item stack that has your component applied will call your component's append tooltip method, allowing you to append as you wish. Here, they are not providing any example. They are just having a record as the component, registering it into the system, and then adding it to the event, and that's it. But I think this is the value, and this is the component type. So on data component types damage, they add this component. I assume if you want your own custom tooltip being added to an item stack, you need to have your own component type and then your own component as the value. And that will make sense because now the component type is customized and t-value is your component that is implementing tooltip appender. However, I may bypass it right now because it looks like a headache, and honestly, Fabric API may change and find another easier solution in next versions, because this looks like a lot of work, especially for having a tooltip for one item, or in our case, for example, goose, 2 or 3 goose will have the same thing. Well, it makes sense because if I want to append a similar tooltip to more than one item stack, then I just need one component and one component type. I don't know, I may add it between the episodes behind the camera because it's just, you know, when we want to have that component, it says component type T type and T value. Then I would add a T here as a generic, and I would say component type, T type, and value as parameters and just assign them here. But right now, I don't want to deal with these headaches. I just want to move forward as fast as possible. And you see that we don't have any problem there. The recipes shouldn't have problem. The screen shouldn't have problem. The status effects. And now, this wood set is something that I need to work on. The library development series, I didn't have anything to do with these yet. So loot table helper, note helper, and word gen. When it comes to loot table, you should be aware that the loot table stuff has updated somewhere in the blog post. They are talking about it. Here we go. The loot table API has been expanded. So if you don't deal with anything and you don't need this functionality, then be it. But if you want to, you can now have more things, as you see inside the example, and you can read it back and find if you want to use it or not. Basically, it says it can use certain extreme usages more conveniently, allows modders to customize the collective output of loot tables. The modify events should be still preferred, okay, but if you want to, you can read and use this one yourself. I'm not handling it here, so that's okay. Model helper hopefully doesn't have anything here, and Origin didn't have any problems. So let's close all the tabs, and now I can publish to Maven. Compared to 1.21.5, this update should go much smoother because in front end, there was really little change. The main changes are happening in back end, especially if you don't use entity models. If you use entity models and animations, things are a little bit different, and you can watch Cup and Joe's videos for that. He goes through these things really fast, but I have lots of things to cover. Okay, tick logic is still under development, so I just need to remove my libraries, and honestly I don't need register there, but because of the testing environment I'm doing it, so I just sync it and bypass it. Then Jira lib. This is one of the more important ones that we will have a problem. So let's go to the Loom, Jiraiya, and we are using base here. I should be able to sync the Gradle now, reload from disk, and then we need to open each one of them and take a look. Now gblock should be okay, I think, because we are not reading or writing NBT or things like that here. So that's okay. The block entity, however, needs some changing. So as you see, we will have problems here. Yeah, because read and write NBT is now different. When we want to write NBT, instead now we have write data that accepts only the write view. We are not accepting NBT or registries. So instead we have view, and instead of all of these, let's comment this guy out. It will be easier. So we want the two initial chunk data, and as you see, it's still using that wrapper lookup registry. So this guy is still returning an NBT compound. However, we were calling write NBT and return the NBT. Okay, we will have a problem here because NBT compound equals that. Now, if we want to and say write data, if we say NBT, we will have a problem because NBT is not a view. So let's go into this guy anywhere, like, I don't know, something that is easier to read, Campfire, and let's see what they are doing. So NBT write view equals to create. This is the reporter with the registries, and reporter is error reporter logging. Then where are you using this? NBT, get NBT. Okay, now we are not dealing with this guy right now. Let's see, if I just copy this, if I go back and here I will say paste, what we were doing were that we were getting that NBT from super, and we don't have anything here. This logger, log utils.get logger. So let's have it on top like so, and let's rename this guy to be lowercase, then return NBT like this. But if I say that this guy is the view, we should be able to do that. Okay, so basically we are getting a logger for logging the errors, then we are creating a new NBT write view for the logging with the registries, then we write the data using that view, and finally we're returning the NBT. I'm not sure if that's the correct one or not, but it should be. Basically, Campfire is doing it, and I assume many other things are doing it. So let's take a look at another thing, maybe. Beacon, for example, again, to initial chunk data, it just returns this.create component less NBT, this write NBT component registries. Okay, here is interesting changes. Well, this class implements, okay, it's block entity itself. Okay, so the block entity has this write NBT that accepts the component and registries. So if I comment this guy out, actually, I think the previous code should work. Take a look. It says this dot, let's get that, write NBT, and this dot write NBT. However, I have an assumption that, yeah, it's protected. Okay, so NBT and registry lookup. This guy is extending block entities. So why is it not accessible here. Funny, isn't it? Because in block entity, this is protected, although it's doing nothing right now. Okay, let's roll back. Let's keep it the way it is, and we'll see if it works or not later. So screen BE should be okay. IBE renderer should be okay. iTick screen handler should be okay. Block state, this is just a mixin, and the storage connector. Now NBT serializer. This is where I said I need to do things. Okay, write NBT. Let's change it to write data and read data to be consistent with the rest of Minecraft code. And here I don't have a read and write because it's just abstract. It means that I need to re-upload my whole base system later. Let's do it again. So I will pause the video and I will republish the base and load everything until here. Actually, I think I need to just do it for the Jira lib, or maybe not even for Jira lib. So let's do it. Let's just publish to Maven local again. And I'm not going to update any one of these because they are not depending on that NBT serializable. Hopefully things will work. This is the only thing that I don't understand. If block entity is marking this as protected, it says writes data to NBT subclasses should override this if they store a persistent data. NBT is a storage format, read NBT. Okay, but then I think my source is old because I don't see read and write data. Yeah, I think my sources are old. So let's go into Jira lib and run the fabric task for generate sources, gen sources, and we will take a look at that again. Now, believe it or not, this NBT stuff is the biggest change in 1.21.6. So if we figure out the base, then we will have easier time when we go for energy inventory at fluid. GUI should be easy to handle because here we have only one helper class, or maybe more than one, I don't know, that will handle the drawing, and that's a screen helper. Okay, things has changed a little bit there, but the rest should be okay, hopefully. The biggest change comes to the NBT for these three, and then our mod, our main mod, that need few more tweaks here and there. So let's figure this one out and dive into the code with each other just to make sure that we understand the NBT stuff correctly. Okay, again, middle mouse click, and we were looking at beacon. So choose sources and properly choose the source for 1.21.7. Thank you. Open. Okay, now let's take a look at that to initial chunk data. It says create component levels NBT, and there we go. Now it changed. So we see that again, it's making a new NBT compound. That's okay. Here we are getting it from calling the super. Then again, looking for a logger and NBT write view create, and this write component less data, and that's it. So in other words, we are on the right track. We need a logger, we create our view, and then write the data with that view, and then returning get NBT. And here he's just returning the compound, and as you see, it's just write view.nbt. The reason that we don't need to create a new NBT is that we are getting it from super. So it looks like we are on the right track. Good to know. Again, if you ever want to create a write view, this is the way. Actually, it's really self-explanatory. We just need a logger to log any errors or any reports, and then we use the registry and create our write view. There is nothing complex there. However, it looks like the 1.21.6 wrapped itself around the concept of optional and gave you an easier time using that optional. We will see it in a few minutes. So let's just publish this guy to local Maven. Although I didn't update the base, it's okay because we are not including that base into our library and we are just depending. And the good thing is that our block entity was abstract, so we don't need to implement anything from NBT serializer or anything like that. However, actually we are not even using it here. Okay, so that's okay, that's cool. So let's move to the next library, that is GUI. This one needs a little bit of work and a little bit of explanation. So let's go for GUI, sync the Gradle. Okay, reload from the disk, and then we can take a look at our codes. Now constants are okay because they're just constant values that I added to the system. Enumeration should be okay, interface should be okay. So these are just constants that I added and they should all work without a hiccup. The enumerations are nothing important. This interface, I draw context accessor. Now this is something that may need to change because, yeah, you see that we have an error here on the shadow. If we look at draw context, that draw quad or whatever it was, yep, Control F, Control V, and we don't have it anymore. So let's see what do we have here. Draw textured quad. Okay, let's compare these to each other. So we have an identifier of sprite, x1, y1, x2, y2, u1, u2, v1, v2, and int color. Is it this guy? Oh, here is the change. Okay, yep, that's the thing. You see that we had a function that accepts an identifier and a render layer. It's changed. Basically, as you see, now we have the identifier of the sprite and the rest up to the color. However, instead of this guy, now we have a render pipeline. This render pipeline is the biggest change inside 1.21.7 and 1.21.6. Basically, what we have, now you see that shadow is okay. What's wrong with you? Okay, here we want the pipeline. Okay, draw textured quad. The thing is that in something like Unity 3D, you have this render pipeline, and this render pipeline dictates many different things regarding rendering. And in previous versions of Minecraft, rendering was all over the place. However, it looks like they are moving the rendering system to use a pipeline. Render pipeline can be defined, if you are really professional, to add your own type of rendering look into the whole thing. For example, in Unity, you have a standard render pipeline and then the HD render pipeline. HD render pipeline is totally different from the standard one, and the standard one can be used on mobiles, for example. The shadows are not AAA quality. Many other things may not be AAA quality, but if you want a AAA quality with ray tracing and everything else, then you have the HD render pipeline that tweaks every parameter in such a way that anti-aliasing is different, ray tracing is different, shadow calculation is different, many other things, lighting is different. So it looks like Minecraft finally decided that they want to use a render pipeline. You can search and Google for this guy and read wiki pages on what is a render pipeline, but this is a big change. Although you just change the name here, instead of a function, you are just using a render pipeline param. However, if we middle mouse click on this guy, you see that now vertex shaders are here, fragment shaders, and many other things, okay? Basically, using a render pipeline, now you can change many things behind the scene, and it looks like Minecraft had done it. So you'll see more of this guy in future updates in Minecraft. Maybe as a modder, you are not going to deal with it unless you want to deal with a GUI draw, and that's all. You just need render pipeline there. However, if you want to do something complex, then maybe you should be aware of this render pipeline changes and track them closely to see what you are doing. For example, if you are writing a shader, you should be aware of the changes here. This one is just a simple record. We don't have a problem there. Abstract screen handler. Let's take a look. Now, it should be okay because we are calling screen utils most of the time. However, here we will have another problem, and that's there. So what is happening on draw texture here is that you see that context draw GUI texture is now accepting a render pipeline instead of a method call. Previously, we had this render layer, and inside render layer, we had method calls that would return something for us. Instead, now we can use that render pipeline, and it's easy actually. You just remove this and you will use a correct render pipeline attribute for a GUI, and that is render pipelines.GUI texture, and that's it. It will fix everything. And because you are using it more than one place, here again, instead of this guy, let's take a look. Render tile sprite. Okay, so here we are calling the draw quad. We need a render pipeline. Okay, so we say a render pipeline, and we simply pass in the render pipeline here, and it will work. Then we have this draw quad again, render pipeline, render pipeline, render pipeline. Now don't forget, it means that we have more problems somewhere else. However, we have another error. Let me find where it is. Here we go. Again, this is the render pipelines.GUI texture, and that's it. Okay, now on import, we can get rid of that render layer. We don't use that. What is this guy saying is that we don't need that Java function anymore. Okay, and one last warning, found problems related to this. Yes, because we are using it somewhere else. So alert, alarm lights are okay, color indicator should be okay, fluid widget. Here is where we are using that thing, okay? And this is a render pipeline. So again, we say render pipelines.GUI GUI textured. And as you see, it will work now because this is one of the render pipelines. And if you want to take a look at that, that's okay. Of course, you need to choose a source so that it will update itself and show you the source. Here should be visible that GUI texture if you want to. Here we go. It's a register of render pipeline builder with the snippet, position text color snippet with location of that. It's basically an ID and then calls the build. So if you want to add your own pipeline for something, you can just look at render pipelines and learn how to do stuff. However, now we should be okay. So what's wrong with you is that we need to make it final. Okay. And then draw background, convert final local variable in constructor. And finally, you have no usage for render layer. Okay, let's go for these guys. These should be okay. Because we are using that screen helper, we should be totally okay. And here it says that extract method from duplicate code. I will not do that. Anyway, and you see it's never used. So you can just move and say more actions and, go here and say suppress for the class. And that will get rid of lots of those warnings there. Again, this is never used. So the same deal, more actions, 3 dots, suppress for class. Finally, this last one says that duplicate code fragment. I will ignore that. So again, you can go with more actions and just disable for method. And that's it. I prefer to see that clean check mark on top. That's a psychological thing for myself. Okay, this guy is again duplicated code fragment, toggle button is okay. And finally, our GUI is ready to be published to Maven. The most important thing was this draw quad thing and the render pipeline and understanding what is going on behind the scenes for that render pipeline and the reason for those changes. We will see a lot about that render pipeline from now on, at least in devlogs for Minecraft team when they are moving toward a more professional, modern looking of their game when it comes to rendering. Now is the fun part, the energy. Let's start with energy because this one is simpler. And under Jiraiya, we have GBase and GRLib. Let's delete those two and let's go for the G energy. Sync the Gradle, reload from the disk. Okay, let's start with energy connector. This implements iStorage and the storage. Let's see what's the problem. It should be some things. Yeah, write data and read data. Okay, this is basically replacing our read and write NBT. So I will just cut these two and I will paste them below because now we will have things that we will move from this guy to this guy. So let's get that, paste it inside the write, and that's it. And from read, I will get this. Now this one won't be as easy as the previous one because here we don't have NBT size because I need to change it to NBT. Okay, let's take a look at here. We say that we want a compound, then we get the storage, the amount, the capacity, and then simple energy that amount equals to amount. Well, I'm not assigning the capacity, am I? I think I can't. Let's take a look. Simple energy storage that capacity equals to capacity. It shouldn't work. Yeah, because it's just readable, cannot assign. Yeah, so that's why we didn't use that. And if it's simple energy storage, otherwise we want to send in the energy. And as you see, that's it. Basically, it was just a duplication, just copy paste. And this write view, let's take a look at that. As you see, it's just wrapping concept of reading and writing to NBT to itself. In other words, when we are reading the amount, we are already using that fallback instead of .get optional thingy. And thankfully, we are just working with whatever we have. And honestly, this read view, I'm not using it and write view. So that is why I said I will come back to this guy. The reading and writing will happen here. I have to say read data and then write data. And in the read data, we will say super.read data. That's okay. Then we get this guy here. But as you see, now we don't have NBT. So instead, we have this view dot, let's take a look, equals get boolean, get byte, get int, get long, optional int, optional blah, get read view that returns a read view. Okay, this is a problem, isn't it? If we use view here, we can't get a list. Instead, list read view that returns a list read view. Okay, and this is the key, and we need the optional one. So dot get list read view optional, just like that. And then we say NBT elements goes to read data for the NBT and the read view. Okay, let's rewrite it from scratch. We say view dot get list view for this guy, and let's read the document if it has. If not, just look into it, and that's it basically. Okay, and it returns a list read view. Then what do we have is empty iteration operator for each read view goes into the energy storage dot read data for the NBT list and the read view. What is the NBT list here? The read view is this guy, the read view. Now the NBT list, oh, it's inside energy connector. Oh, okay, you know what? Let's take a look. For energy storage in storages, we say the write view or write data, or right now write view dot put long that, and if we return the write view, this is why I said we will come back to this guy, okay? Then, oh no, we want a list. Okay, let me think. Problem is that this guy returns a read view, and inside the read view, we have a list read view that iterable of read views. So maybe we want this guy here, okay? So when we are writing, we say list read view, list view equals to new, come on, import the class already, equals to new that, oh god, no, that's right. Can we say write view dot put a list somewhere? No, put that uses a codec, boolean, byte, double float, int array, long, nullable, short string, and that is an interface. Let's see, find usages. Okay, I need to create the sources here again. Now let's choose the source. Okay, now I can find the usages for this guy from somewhere. Hopefully it's on read context on the storages. So these are just read storage, NBT read view, read context. No, they are the same thing. Okay, so we'll read chunk data. Let's take a look at that. Write chunk data, because at some point it should write a list and its entities. Let's take a look. So it says NBT compound dot put entities NBT list. So it's putting a list inside the compound, and then when it wants to read the list, it goes here and says that, okay, it has a read view, list read view, get list read view entities, list of entity equals to entity type stream from data, this list view, whoa, okay, let's see. Let's go back. So write data is actually just returning an NBT list here. So if I want to write properly, what I had before is this. I will put it under an NBT compound like so. So let's do that first. So we say view dot, here we were saying that NBT compound, put the list in it, and then, oh god, it's confusing. Unfortunately, the blog post has nothing about this. As always, they do things in a hurry and they don't cover everything. So they say that view.read, get optional string, get optional int, and they put a nullable with a codec for a record, then put an integer, and that's it. Nothing about a list. So if we want to cover this guy, it means that, I think it means that, oh, I don't like that. I really don't like that. Energy storage, that's energy connector. Okay, let's take a look at simple energy storage. Maybe that has something, and nothing is here, and nothing is here. Thank you very much. I don't know. This is a hell of a headache right now. Okay, let's see. We have only view.put. Now the key is this. Then it asks for a codec and then the value. Now the value will be this. And write data, that means the view. And it's actually not even using the view. However, for the codec, this is NBT list, isn't it? NBT list. Do we have a codec there? No. Dot NBT element, NBT compound. These are packet codecs. Only we have NBT element here. Okay, let's say that we done it. So this is writing it. Then for reading it, we go back here, and inside the read here, we are getting NBT list here. This is where we need to change the stuff. So what did we do now is just, actually I don't like this because I'm jumping all over the place. What I want is that I should say energy storage dot, not in here, here, I should say energy storage dot write data to the view, and that should be it. So I will cut this, I will come back here, and this should return void. So I should cut it from here and paste here. So we should say write view dot put, and the value would be the list. So that's it. So coming back here inside write, we would be void. And honestly, I don't think we will need this TNBT anyway. So let's get rid of that. And here, where is that? Storage connector, my storage provider there. Yeah, NBT list. We don't need that. So it's inside GRLib, the util and the storage connector. So we won't have that. Yeah, I know. I'm jumping all over the place, but that should be okay. Then here we should say, instead of all of this, we should say energy storage dot read data for the view. That would be all. So don't forget, this is the key. Let's go back, and here we won't have that. Okay, let's take a look at what we were doing here before. Before, we were getting an NBT compound from the index, and then from that, we would get the amount because we were putting it inside the list and the capacity is not used. So we were putting it inside the list, and now we want to get it. So we say read view dot get list view using this key dot, well, I can use for each, or I can use iterator. Let's get the iterator, and I will say var iterator equals to that, and this should be iterator of something, iterator of read view. So iterator of read view. Then what's wrong with you now? Iterable, sorry, iterator. Then we can say for I equals to 0, I less than iterator dot, please give me the size. I hate iterators. If I can't have the size, okay, for read view inside the iterator dot, how would I, okay, let's see, dot for, can I use for view inside that? Thank you. All I want to say that long amount equals to view dot get long. There we have it. This is the amount. Then the rest of the stuff. Cut, paste. We don't have the storage because we were getting the storage from the index. Okay, we don't have index, so we say int index equals to 0. And after we getting it, we say index plus plus for the next iteration. That's basically a for loop concept. So that's that. The only problem is that, yeah, we are not overriding things properly here because we changed the base. So here, instead of all of this mumbo jumbo, I just need the top line. Energy storage read data and then energy storage dot write data. However, yeah, it's going inside the energy connector. So it reads and writes the amount inside this key. We get that key, the list inside that key, and we move forward from there. Hopefully it works. Crossing my fingers. Okay, then we move forward, assuming that is correct. Then we have I energy connector that has nothing to do with us. These guys should be okay. And finally, energy helper should be okay. As I said, the NBT stuff is changed and it became a headache. Now I need to really push that base again and GiraLib again. So coming to my Maven local, finding my own Maven. As I said, I need the base and GiraLib to be gone. And then I will go back to base. I will publish it to Maven again. Honestly, I was not sure if I need anything here or not. I hope it works. So that's built successful. Now I need to go into GiraLib, sync the Gradle. It's done. Before that, make sure that I don't have anything down here. I'm not sure why it's not doing it anyway. It's interesting. It's not putting it anywhere else. Okay, let's open our connector and make sure that we don't have any errors there anymore. Shouldn't actually. Oh, wait, I see something. This is saying that we are using raw. Did I forget to remove that raw thing from their interface? NBT serializer. No, I did remove it. So it's not reading it properly yet, as you see. Reload from this. If it's not working, there is only one way. Invalidate caches and just restart. Okay, let's see if this fixed problems or not. And now this dude decided to sync everything. Okay, it will give tons of errors. I don't care. Right now, all I want to see is that this guy is still empty. Okay, there is an easy fix for that, although I don't like it, but you can nuke that .gradle folder completely. There we go. It's under remapped now. Okay. Nuke the base, and I will stop every syncing because that's meaningless. Okay, all I need is the GiraLib to resync. And now I will delete this Jiraiya folder because it's just making no sense anymore. Okay, I don't have that remapped here. Interesting. Oh, it's here. Okay, so that's gone. And from here, I will delete the base. Yes, I need to resync everything, but I will do it off camera. Now we should see that this guy is happy. And if it's not working, I will tell you what to do. Just let me clean my repositories. Okay, right click here and reload from disk. It will reload and you see that base is showing up and everything is okay. And you see that now NBT serializable is okay. So GiraLib, we want the tasks, publishing, publish to Maven local. Now it's published. Finally, we go back to G energy and resync the Gradle. It's successful. Right click and let the indexing finish first. Reload from the disk. Okay, they are there. Now we have read data, write data. Thankfully, we just need to delete the read NBT. And honestly, I think this is a cleaner solution because before in my library, I had to remember that I had a list. I should retrieve the list and put it somewhere. Now I just call read and write data, and the storages and connectors should handle everything. And thankfully, there is no error there. Why are you telling that you should sync the Gradle? I don't care. And that's it. So it's insisting on syncing the Gradle. because now it's foolishly wants to sync everything else. Now let's publish the G energy. We are finished with you. Let's publish it to the Maven, the local Maven. And as it's progressing, I will sync those that I know can be synced, like so. And then we can progress forward. Now inventory should be easier. So let's delete that. Let's go into Loom, remapped. Honestly, the new system that puts a remapped thing under this remapped mod, not under net fabric yarn, makes much more sense. Right click, reload from disk, and I will take a look and I will keep an eye on the connector for energy and the block entity, although block entity is simple on the second monitor because things will be identical. So here we will have our base as the connector first, and as you see now we have an error that says implement method for read and write data, and we have NBT stuff somewhere here. So I will cut these, I will paste them below and take a look and compare. So here on the block, on the connector, when we were writing, we were getting a list, and let's write it again. So this is NBT list, we call it list equals to new NBT list. Then we want inventories for each inventory. Okay, this dot inventories dot for each inventory goes into. Now that we have the inventory, we will want an NBT compound. Let's rename it to NBT just to be consistent between my libraries. And then we say NBT.add. Now this is for inventories. Inventory is simpler because now we can say inventory dot, what's the problem, right? Data. Why can't I see it? NBT.put, the same thing. Okay, let's just cut that, put it there. But instead of NBT.add, and not resolve add. We'll find that. Let's make this guy that. Then we want the right view and not this guy. Now what's wrong with that add? That put that, and what's wrong with you? Okay, I'm missing something here. An extra parenthesis. Now what's wrong with you? It's asking for the NBT element. Of course, it's the, it wants a key first, isn't it? And I think I can send in inventory directly. No, okay, get held stacks, but we need a key because, okay, let's say that like that. Then the element, I shouldn't need that part. Let me take a look. Just do that and put a semicolon. Yes. So inventories that write data for the right view with the inventory that get held stack. Now when we are reading it, here's the problem. We need this somewhere, and here is read data. We don't need the registry lookup, and NBT compound is now something that we need to handle because here we are not putting it inside the compound. We are just directly writing the data on the inventories. NBT.put, here we will say the same thing that we had, comma, inventory plus BE keys dot has inventory. What's wrong with you now? An extra parenthesis, and the element now says that provided void. We need a defaulted list of item stat. Well, this is right data, but it returns void now. Well, let's see. If I say read view, then we have inventory. If we do this and we say inventories dot for inventory, and we cut it and paste it there, I think it will work. So because we are getting an inventory from the index, well, guess what? Now we are looping through them, and then we just read the NVT data. So we don't even need that compound anymore, do we? Like so and so. Let's hope that this works. And we don't, and we don't need this region section anymore. Okay, then the predicate should be okay. Here, well, we have the read data, and here we will say, you see what we were doing here? Now we say inventories or inventory dot read data with the view. So none of that. Basically, I wanted to have this key, but we are not using a key here. Problem is that this guy returns void. So if I want to have any type of key here, then I won't be able to. So it says write the inventory to NBT. This method will always write to the NBT, even if stacks only contains empty stacks. C write NBT compound, defaulted list boolean block for the serialization format, passed NBT. Okay, both of them are using write view, read view. And again, I'm fairly sure that I'm dealing with old versions. So God, I hate it, but I have to generate the sources. So again, let's take a look at this write data, and hopefully how can I change the source here? Because these guys doesn't make sense anymore. NBT compound, when you are not having this method. Yeah, I think we are dealing with old sources. So how can I change the source here? Let's go with this guy. It's still not telling me to read the new source. Okay, write view uses a put. Okay, so if we go back here, we have this list. So if I go for the for each loop like that, and if I say write view.put, then we need a key, okay? Now here's the thing. This guy was supposed to automatically do everything for us. And I'm thinking like, we are not putting it inside the list right now, are we? And I can't just put, there's no way of instantiating you, is there? Let's take a look at simple inventory. Now, as I suspected, not reading and writing. Read data list. Oh, look at that. Two data lists. Oh, wow. Okay, we need a list of item stack to data list. It returns an NBT list. And then read data list from NBT list. Okay, so can we say inventories dot no, that's simple inventory. Each inventory returns a list. Okay, so instead of this, we will say list dot add an NBT element, and that is inventory dot to data list. And here we need the L stack, maybe. No, I was so hoping. Okay, to data list. It's list appender, right view list appender of item stack list. List appender that add value. Oh god, don't tell me that I need to iterate through every one of them. Actually, that dot for L stack. Now I need a list appender of item stack. Item list equals to import class goes to new. That's an interface. What was I thinking? Actually, yeah. Okay, let's find the usages for this guy and write inventory. View.get list appender. Okay, that's right inventory, get inventory. Okay, this is what we want. So none of that. Inventory that, and this is right view, inventory, and that. Now what? Provided void. Okay, it asks for list appender. Okay, this is the list appender. So where was I? To data list of that. What now? Provided void to data list, get list appender, a list appender of blah, and I assume that this will not work. I'm so lost. You know, it's working on a simple inventory, and it's write the inventory for a simple inventory, you see. Then how should I put it inside another compound using put? Because this is what I want. Let's see, we have a list, then let's go inside inventories.for. So we have the inventory, then for each one of them, we want an NBT compound. Let's call it NBT equals to new NBT compound. Then if I say NBT dot, well, that's what I want. Okay, that's what I want, one of these two. However, if I go the other way, the inventory dot don't have write NBT or anything related to data here anymore, and this is just that void, and this is reading it. Let's see, if I say inventories dot write data to the NBT now as a compound, yes, it accepts the view. Oh, I'm derping. Okay, and then the inventory dot get held stack. Now what? Oh no, right view, and we provided NBT compound. Okay, let's say that we got that part done. So we say list.add the NBT. Then at the very end, we want to add it to the right. And here we would say right view dot put the inventory plus the keys dot has inventory, the codex dot nbt element, and finally the list. However, now we have this problem that nbt compound is not a right view. What do we have with nbt right view dot? Can we use something else? Like, no, can we cast it to a right view? Let's take a look at nbt compound first. It implements nbt element. An nbt element, NBT primitive, NBT end. It's an interface. So we don't have any way of getting a right view from this guy, do we? For each type, these are put, optional, get byte, these are gets. God, it's so frustrating now. None of that. God damn it. There is no way of casting at least the NBT compound. So apparently, God, I hate it. There is no way of directly using NBT compound and putting it inside the right view. So let's see what we can have. This part is correct. For put, we can ignore that part. Let's go with this. Remove everything and say that, well, we need that NBT list anyway. Let's call it the list equals to new NBT list. Then we have a loop for inventories.for, and we call it inventory. Then we want an NBT compound. We call it compound equals to new compound. Then, God, this will become ugly. We can't use inventories.write data, okay? We should be able to say that var stacks equals to inventory that get held stacks. Then we want to loop through that. So for I less than stacks dot size, here we say item stack equals to the stacks.get at I. Then let's move this guy in. Let me say stack dot, oh god, can we put it here? Compound dot put, I think we can. Slot plus I. Then we have item stack dot codec. Then for the last thing, we need the value that will be the stack. So we put the stack inside the compound. And finally, we say list dot add the compound. Wow, this is ugly. I'm telling you, this is ugly. So one thing is that I'm creating one compound per stack. We don't need that. We need to put every stack inside a single compound and add it to the list. And we need to do it here. So basically, we put the slots inside the compound and then add the compound to the list. So for reading that, we say NBT list, we call it list equals to read view dot, can't we just get simply something? We have this key, okay, and we call it var. Actually, let's do this. Dot for read view, and we need an index, int index equals to 0. Then we say t inventory equals to inventories dot get at index I. Then we say var stacks equals to, now we can't use get help the stack here, and this is index, by the way, not I. Now we say int slot equals to 0, then we say while true, we say string key equals to the slot plus that slot, because that's the key we used here. Then we say if not view dot, okay, let's drop that. Let's say that for I is smaller than inventory, not index, inventory dot size. Okay, we don't need index anymore. No, we need index, sorry. Now that we have I, we say string key equals to the slot plus I, item stack equals to view dot, what do we have here? Oh, I had to pause the video, and guess what? The solution was much simpler than what I thought. Now, I dived into the right view and I noticed that there is this list view that we can use. So we simply say that right view get list view. Take note, it's happening inside right data. Now what will happen is that if we don't have a list with this key, it will create one for us. So it will not error out and it will give us a list view. So we just simply go into each inventory and we get a right view. From that, list view.add means that now we have a new right view compound, and we can use that with held stack on right data. Now, when we want to read that, we use the index, and at the end of each for loop, we increment the index. So we should make sure that index is always smaller than the size of the inventory. Then we get the inventory of that index and held stack, and just using the view from this list to read the data. As simple as that. So now, hopefully, we can close all of these and continue. So predicate key is okay. Then we go into J inventory, and instead of reading and writing the NBT, wow, look at this mess. We don't want any of that. Instead, we say write data, and all we are doing here, we say inventory dot write data with the view. Simple, clean. Let's take a look at this guy. There shouldn't be any errors. The interfaces should be okay. The record should be okay. The screen is clean, and then these should be just okay, because we are just going through the slots, and thankfully slots didn't change at all. Now, as I'm talking about the slots, there is something inside Minecraft that I don't like about the slots. We can't hide a slot. That plays a role when we want to talk about tabbed layouts in the library in future, and I will see if we can find any way around it. That's everything for our J inventory. So now I can say, hey, JInventory, please publish to Maven local, and I will keep that connector up so that I can take a look at that connector for the next one, because, oh God, fluids are always headache. The next one is gfluid. We simply go and remove the folder Gradle, and from the cache, we don't need that Jiraiya folder at all. So let me see what are the dependencies here. I assume that we are depending on the J inventory. Yes, so I need to wait until the J inventory is done. Gfluid, sync the Gradle. Now, as the Gradle is syncing, I open the fluid connector, and it looks like we will have easier time compared to inventory because it's more like using the energy. However, inside the energy, we just had the amount, but here we have the fluid type, the variant to be assigned to the NBT. However, again, we will have a list. We will go through storages, and I will move away from this for each, but that's one thing. Then we have compound, that we put things inside the compound, we add it to the list, and instead of returning the list, at the very end, we will write it to the view. When we want to read it, we need to have an index, then we will look through the views, and from each view, I think we should be able to directly read the amount and the fluid variant, and then we check if the storage is this guy, we will set the amount as variant. Otherwise, we were throwing an exception. Now, this is something related to my library, and I'm not gonna dive into it, but if you have seen my videos on the library in future, you will notice that I'm debating here on using single fluid storage or a storage of fluid variant. And the problem was this read and write NBT, get amount, get capacity. These things would become a headache. So I made the decision that this time I will go with single fluid storage and not a storage. If I would want to move toward the storage, I can use the same tactic that we are using on energy connector with the transactions. However, right now, this is what we have, and I will work on that in another video related to the library itself. So let's wait for the Gradle to sync and we will continue. Okay, as you see, we have a problem here again because we need to implement the read and write data. And if I find my two methods for reading and writing NBT, I will cut them from here and I will paste them below. Let's start with writing the data. As I said, it's really closer to energy system compared to what we have for the inventory. So we say NBT list, we call it list equals to new NBT list. Then we say the storages dot for. So we get T storage inside the storages. We say NBT compound, call it compound equals to new NBT compound. Then we say basically this, the compound dot put long, put the fluid variant, and we will take a look at this, but then we want to add the compound. Now, what was going on here? Single fluid storage. Oh, we need to check this guy. So if we are type of single fluid storage, then do all of that. Otherwise, we don't want to do anything like that. At the end, here we say the write view dot put, and the key that we want is fluid plus be keys dot has fluid. And I know it's a very stupid key because it will become fluid dot be dot has key, something like that, has fluid, and it's really stupid, but it is what it is. Codex.nbt element and then the list. So that's all right. For our read, again, we want int index equals to 0. Then we go for read view dot get list read view with that string. Just copy paste it so that we don't have any typos, and dot for, and we call it view. Now here we check if the index is greater or equal to the storages dot size. We will break. I added this check into the energy system 2 when I was pausing the video to read the documents. Then we say long amount equals to view.get long, and the key here is the amount. Then we want a fallback that is 0L. And for the variant, let's get rid of this guy. We say variant equals to that. Well, let's take a look. We say var variant equals to fluid variant dot codec dot decode and nbt ops dot instance. And here we want a compound. Now we don't have the compound, but we have the view. So view dot get. However, we don't have, oh God, okay. Get read view, that returns a read view. That's not what we want. Actually, we have a compound. Okay, now how would we decode it? We get boolean byte, get class, double float int, list read view, get long, get optionals, get read view. Oh, that's not what we want. Get typed list view. Okay, the view has a read method that we can use. So the key here is the fluid, and the codec is nbt compound dot codec. Then we say if the variant now is optional of nbt compound. Okay, so we should call it variant or optional variant. I don't know. Optional variant compound. This should work because here we are using a new compound. I hope it will work. Honestly, this thing is so new that there's no documentation out there anyway. So we say if the, let's rename this guy with lower o. So if optional view compound that is present, then we say NBT compound, and we call it NBT equals to the optional dot get. Finally, we can get the compound out of there, and then we say fluid variant, call it variant equals to fluid variant dot codec dot decode with NBT ops dot instance and the NBT. And I think we have something here because the rest is the same, hopefully. Yes. Now that we have a compound, we can say, what did we call it here? We didn't. So we need this check on top of everything before going anywhere else. And what did I do here? Oh, I need the storage. Okay, so that's that. And here I will say actually right here, storage dot amount equals to our amount. And finally here we say, I should use this guy and I should be able to cut it and paste. So finally that we have the variant, instead we can say not that, the single fluid storage dot variant equals to that. And now it should be able to replace it with this guy. Okay, so let's move it to the second line and this guy here, move it down like so. Okay. Let's get rid of this guy. Actually, we will use this on the else because that makes sense. And this will be it. Now, I'm debating on using NBT list because from inventory connector, we learned that we have this right view.list view. Let's move toward using that. So it's equals to, let's remove this part, right view.get list. And for the content as a key, we will say fluid plus be keys dot has fluid. Then we loop through the storages. We say if the storage is that, don't need a compound here. Instead, we will say right view and we call it fluid view equals to now the list that we have dot add. Then we can say the fluid view dot this part put long. Then here we need to change things. We say NBT compound NBT equals to fluid variant codec encode get or throw. What's wrong with you now? The required NBT compound provided NBT element. Did I miss something here? Get resource instant new compound get or throw. Okay, let's fix that at the very end. Here we say the fluid view dot put. The thing that we want is a fluid comma NBT compound dot codec and fluid. Actually, I think I called it NBT. And we don't need to write anything like this anymore. For the read, we still need the index. We will loop through these. And if index is greater, then we get the storage. Then we check the storage. For the amount, we say view dot get long directly for the amount. And here we provide the 0L. Oh, actually, I'm reading it in a wrong order. Okay, 0L. Then optional of NBT compound equals to read fluid with NBT compound codec. Then we say if present NBT single fluid variant equals to blah, 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 else throw. Okay, and what's wrong with you here? It can throw null point exception. Why? I don't care. Okay, so let's go back to the problem at hand. It says cast expression to NBT compound. So if I remove that part, what will I get is actually, let me see, it's data result of NBT element. I need to change things. Okay, data result of NBT element, NBT equals to that. Then I need to handle things. I say if the, let's change it to encoded, if the encoded dot result that is present, then we want to say NBT element, we call it element equals to the encoded dot result dot get. Then we say if element instance of NBT compound, we call it compound. Then I think we will say, yeah, fluid view dot put the fluid comma NBT compound dot codec comma compound. Else we will throw new illegal argument exception or what, I don't know what sort of illegal things we have. Now let's go with argument exception. And here we say encoded fluid variant is not an NBT compound, just like so. We don't need that anymore. Now here is where we are outside of the, let me see, is present. So here we say else, again, throw new, illegal argument exception, why not? I don't care about what type of exception I'm throwing right now. encoded, actually no, what I'm doing. We say a fluid variant encoding failed loss encoded dot error. So we get the error and that should be it. So as you see, new NBT stuff is a headache. And honestly, I'm not sure if this will completely work or not. I hope that it's working because as I said, there is no documentation about this whatsoever around the web. Now that encoding, what's wrong with you? Okay, a typo. And as I said, hopefully this is the proper way of doing things. Now that we established this guy, I need to go back to my energy one and fix things based off the fluid one. So when we are writing the NBT, we will get this, and this is energy has energy. Then we look through storages and we say, well, here we don't care if we are a type of a storage or not. Instead, we want a list. So let me get rid of all of that. Actually, let's paste it on top. We get the list. Then we say that, let's call it energy view. Okay. Then we say energy view dot put long that. We don't have any fluid variant here, thankfully, and we don't want to put something there, so that should be it. Simple enough. Then we read, we loop through everything. We say amount. Actually, we can, let's see. I'm gonna put this guy inside the check and I will put it here. So the amount equals to that. Otherwise, I will get it here. And what's wrong with you? Okay, the amount equals to that. Parent equals to that. Parent is that. Okay, I will take this guy and add it here. Now, this looks robust enough using the right view list. And I hope that we had covered this guy too. Okay, let's move to the fluid BE. Now, it's much easier this time. So read data. All we are doing here, instead of all of this mumbo jumbo, we will say that fluid storage dot read data with the view, and then we have the write data. Here we say fluid storage dot write data with the view, and that's that. So hopefully the other things are correct. We don't have any problem so far. Let's take a look. We don't have any problem here, no problem here, no problem here, and fluid helper thankfully is correct. Okay, that is our fluid storage. Wow. I did change the energy. I didn't change the inventory, did I? Because I think in inventory, I correctly used that view list, yes. Okay, so from my Maven, I will remove the energy because that's wrong. And then I will publish the fluid one and then the energy one. So the fluid is done. Let's publish the energy one. And then we can continue forward because the next stop is actually our gmachina. However, gmachina should be much easier because it's just relying on the previously developed APIs that we have. So let's sync the Gradle. And as it's syncing, let's take a look at our Java classes. Here you see that we are reading and writing. However, this time we just need to add the energy stuff because we are already extending from gfluid one. And we already covered the inventory in the fluid one. And we already covered the fluids in the fluid one. If you take a note inside our block entity, you see that this guy is extending the J inventory. So we have covered the inventory in J inventory. We have covered the fluid here. And here in Machina, we have covered 2 of the 3. So all we have to do here is cover the energy. And thankfully, all we need to do here is saying energy storage dot read data with the view. Of course, we need to update things, but energy storage dot write data with the view, and that would be it. Everything else should work. So the only thing remaining is that gmachine block, and this is an extension of fluid container block that only adds few properties. So this guy shouldn't have any problem. Just wait for the syncing to finish. Okay, now just reload from disk. And finally, we say read data, and we want this to be here, and write data. And finally, we want this guy from here, here, and this is correct anymore, and the block is correct. So we are done with Machina. So we go and publish it to Maven. Finally, we can focus on our main mod, and our job is not done yet because other than the NBT, some little things has changed here and there, and we need to cover them. Got the project synced, and as you can guess, on our first machine, Gem Cleaner BE, we have a problem with NBTs. Well, this one is easy to fix. This is write data, and here we are using the single fluid storage. So let's say this dot fluid storage, and let's see we have write data or not. Funny enough, we have it. So that's that. And finally, read data. We say this dot fluid storage dot read data with the view, and that is that. So unlike our own library that we have maps and lists, and we need to iterate through the list. Normally, if you are having a machine that only has a single fluid storage or a simple energy storage, reading and writing NBT is easy. However, our job is not finished yet because, as I said, we have many more things to cover, but this video took way too long to fix those NBT headaches. So in the next video, I will come back and move through everything we have and fix everything inside our main mod.
If you like these videos, please subscribe to the channel, hit the like button, and turn on that bell so that when I publish a new video, you will get informed. Have fun, everyone. Bye.